All right. So, hello everyone. My name is Pranesh Sharma, and I'm working in Tech Solution as an electronics engineer. My company deals in the manufacturing of ultra high frequency RFID tags, readers, and antennas. RFID is an emerging technology, and like a few of you might be familiar with RFID. Some of you might already be using RFID modules with, I don't know, those electronic enthusiasts of our college. However, you all will be using RFID in your daily life, that I can be sure of, because RFID is such a vast technology. It is being used everywhere. Radio frequency identification is the full form of RFID, and it is a really, really vast topic. So, radio frequency identification uses electromagnetic fields to automatically identify and track tags attached to objects. So basically, it's kind of a tracking system, like we have barcodes to track what kind of object we are dealing with and QR codes. So RFID is a similar technology. However, there are really, really, really huge number of applications where RFID is being used. So, as this topic is really vast, so I'm only going to be scratching the surface in this particular webinar for this technology. And after this webinar, you'll have a fair bit of understanding and knowledge about RFID technology. The scope of RFID in the near future is massive. It's expanding exponentially and replacing barcodes and QR codes. All right. So, with our intro out of the way, let's talk about what exactly RFID is. So, RFID stands for radio frequency identification, and what better way to understand RFID is to look at some examples and the applications where the RFID is being used. This will give you a fair bit of idea about what exactly we are talking about. So you might be familiar with the toll roads nowadays having a mandatory fast tag, so that you need to install on your car's windshield in order to access the toll roads. Nowadays, the cashless system is being implemented everywhere. You might be familiar with this thing. Secondly, you might be familiar with the contactless payment systems and the tap to pay systems that you all use. So these are the examples of RFID, and these are only two examples of RFID, and RFID is being used at multiple places. Be your car keys and all that stuff. I mean, everywhere RFID is being used. So, what exactly happens in FASTag is a tag is attached to your windshield, and a reader that is just placed above the toll booth reads that tag, and accordingly, it just deducts a specific amount from your account, because all of the things are linked to a database. And RFID just provides enough information about a vehicle that it can just link your car to its database and accordingly deduct the amount and just calculate what is the time that is. For example, some of the FASTag just like works for 24 hours, and if you just like use the toll road multiple times within 24 hours, so the charge won't get deducted. So all of that is being handled by the servers and all the databases. RFID just gives a kind of a pointer to a particular location in the database so that the processing can happen, and this calculations and all this stuff can happen. Similarly, the contactless payment. So this uses a subset of RFID, that is the NFC, or the near field communication. So the near field communication basically works like, I mean, you have a reader, and in your card there is an RFID tag built in. So that RFID tag gets powered by the reader, and then it just like sends out some encrypted data that the reader has to decrypt in order to make the payment. So contactless payment is being used everywhere nowadays, and most of you might be using it yourself as well. So this is one of the biggest example of RFID. Even some of the phones are having this NFC nowadays. So not some of, I mean all the phones are having NFCs nowadays, so that you can just like program your cards into your phone and then just do contactless payment from your phone itself rather than using a card. Another example of RFID is Metro card. So the smart cards that we people use in metros is an example of RFID. And this is like widely used, and most of you people would have used Metro cards. So, and another example is the attendance system. Like in most of the offices, you are required to have a card, and you have to just swipe the card against a reader in order to mark your attendance. For example, in my office, I use this blue colored tag right here. So this is a keychain kind of a tag. So this I have to just swipe every day in the attendance system. So in order to just mark my attendance. So this is kind of an application of RFID. And then we just come to what exactly is the RFID system. So let's just get into the theory part now. So RFID is basically it just consists of three main hardware components, and then there is some software part and the computational part. The computational part we are not gonna be covering in this particular webinar, as we people are electronics engineer and we usually deal with the hardware stuff. Software part is also important, but usually the ID people take care of the software part, so we people don't usually deal with the software. Anyways, coming to the first thing, the first and the most important component of an RFID system is the RFID antenna. Now, antennas can be tuned to multiple frequencies, and according to the RFID, I'll just tell you later on in this particular webinar that there are multiple frequencies on which RFID works. So according to that, we have actually categorized RFID into four main categories. So we'll just talk about that later on in this webinar. So RFID antennas, so what exactly happens is that the RFID antennas just sends out a signal to a tag. Now, RFID tags usually don't contain any power source. So the RFID antenna is connected to the reader, okay? So the reader basically sends out a signal to this RFID tag, to this RFID antenna, which is being transmitted in the form of EIM waves, electromagnetic waves. EM waves, sorry. So these like are transmitted in the form of EM waves, or sometimes it's also like sent out through inductive coupling and all. So we are just going to discuss it in the later part of this presentation. So this basically powers up the tag. Now a tag is a totally passive device, so it does not have any power source. What happens is that whenever it receives a signal, the chip, right here you can see on my screen, so there is an RFID tag, and on which like you can see a diagram for the RFID inlay that we people use. This is called an inlay. So it contains a coil and a really small chip. All right. So this small chip contains all the data for the RFID tag, and it is usually soldered on directly to the copper antenna. So the antenna can be made out of copper, silver, or any other material that usually is like laid out on a polythene material. So basically, the RFID antenna will send out a radio frequency wave to this particular tag. The tag will receive this wave and it will just charge up this chip right here. So there's some form of rectification that is going on and some kind of power storage that is going on in the chip. So I'm not going to go into the detail about the chips and all that stuff. So this is the introduction to RFID. So let's just keep it to a basic level only right now. So this basically gets powered up. So the chip gets powered up and it sends back a radio signal back to the antenna. Now this antenna has to receive that signal and it has to transmit it back to the reader. All right. So the reader gets that signal. It just gets the data out of that RFID tag. So it is usually in the form of a binary code, and it's for the ultra high frequency. It's usually a 96 bit data, 96 byte data. I'm sorry. So this reader will then communicate with a computer or any other particular microcontroller in order to connect to a database. So this connection to the computer can take place with like in multiple forms. So there are multiple communication protocols that we usually use from the reader to the computer. I'm just going to discuss it in the later part of this presentation as well. So coming on. So this is how a basic RFID system works, and this is what we people usually deal with. So this is a basic RFID reader, and this is a 8-port reader, and this is a really high-end reader that we people actually manufacture in our company. And it just gets connected to this particular, so over here on the bottom right corner of my screen, you can see an RFID antenna. So this antenna connects to this particular reader using a coaxial cable. Now, we people use a coaxial cable in order to reduce the noise and and to just maintain the signal integrity. So you people, those of you who are in the first semester will be reading about coaxial cables in your syllabus. So do focus on that particular part. It's important. It's used everywhere. So the coaxial cables usually connect the RFID antenna to the reader. And then from the reader, it usually gets connected to the PC or for example, if your microcontroller or Raspberry Pi through various communication protocols. One is the RS-232. So this is usually plus minus 12 volts signal is being provided by the RS-232. So it's a form of a TTL communication. So anyways, so this is a Ethernet. So anyway, the RFID reader may get connected to your PC via the Ethernet. And nowadays in the modern systems, we people use Ethernet over RS-232 or this RS-485 because Ethernet just provides a really long range. And some of the older systems may use the VGAN as well. So VGAN is another communication protocol that was used in the early 90s. So and then it can also communicate using the USB protocol. So it can just like directly plug into the USB port of your computer, the RFID reader, and it can just like send out the data to your computer so that it can be connected to the suitable database. The RS-485 is another communication protocol that is used. So and there are two wireless communication protocols that we people generally use with these readers. That is the Bluetooth and the Wi-Fi. And with these particular readers, which are fixed in nature, so we usually use Wi-Fi over Bluetooth because of the range and so that we are able to connect multiple readers to a single server. Anyways, now going a bit deep into the classifications of RFID based on frequency. So this is what I was talking about in the earlier part of my presentation. So RFID, usually we don't usually think about what frequency the RFID is working on, but there are mainly 4 types of frequency bands that the RFID works on. And out of these 4 bands, the first two, the LF, HF, and the UHF, generally consist of passive tags. It means that the tags are not having any power source within them. So it usually takes power from the reader and then it just sends out the signal. Whereas in the active tags, the the microwaves are used in the active tags. And these kind of tags are usually more expensive and these have a really high range. However, these tags are usually not used in RFID systems like in day-to-day basis, or like these are not extensively used. So anyways, coming on to the LF. So LF will work on the frequency range of 125 to 134.2 kilohertz. So, and the HF works in the frequency range of 13.56 megahertz according to the table. You can just see the table. So these two frequencies are actually coupled to the reader via inductive coupling. So it's usually how wireless power transfer takes place. So wireless power transfer between two coils. So two coils will have inductive coupling. So this is how the LF and HF usually communicate with the reader. Whereas in the case of UHF, the inductive coupling is not there, and we usually use the backscattering phenomenon to couple to usually send out the signal. Basically, this is where the EM waves start. So from the UHF tags, so the UHF tags usually work in the electromagnetic spectrum. So these usually couple using the electromagnetic waves. So we are just going to discuss it in the later part of this video. The range of the LF and HF is really low, as these are based on the near field communication, because the inductive, anything that just couples inductively will reduce, the range is not going to be really great. But whereas in the case of UHF and the active tags, so the range is really awesome. And for the UHF tags, we people manufacture readers that are providing the range of up to 15 meters. So even 15 meters is also possible with UHF. However, with HF and LF, you have to just get really close to the reader. So your NFC is basically a subset of HF, high frequency. So the low frequency, usually like the cost of the low frequency is usually great. So it is a bit more expensive to manufacture, as a lot of windings are required for the low frequency tags. High frequency is relatively cheap, and the ultra high frequency tags are usually the cheapest. And the active tags are the most expensive tags. So obviously these are containing the power source, and then there are a few more things that the active tags contain. So I'm not going to discuss active tags in really great depth, because it's just going to be out of the scope of this particular presentation, and it's just going to take a lot of time otherwise. Anyways, coming on to the HF and the LF. So these are basically, so as I told you, that these are used for the near field communications, and also these usually don't have a really great range. And then the memory of the LF tags is the lowest. Active tags usually have a much higher memory. It's like greater than 32 bits. So that's Anyway, so the LF tags usually have a 64-bit memory that is built into the tag. The HF has a 248-bit memory, and the UHF that we people deal with, my company deals with, is having a memory of 96 bits. So the penetration refers to like how well the EM waves are able to pass through a material. So for LF it's like really good, HF is good, and UHF is poor. And for the active tags, that's a microwave that's working the microwave spectrum, so it's also very good. The data rate that basically is how fast these tags can communicate with the reader. So it is slowest for the LF. As you can see that the frequency on which this is working is really low, so therefore the data rate is just gonna be low. So with HF, the data rate is fast, and if you want to make wireless transactions, and also you do need to like communicate with the reader at a really high rate, so that in order to receive that encrypted message. So all the data is encrypted within your credit cards and all. So the message is later on decrypted. So that is like kind of a layer of security that we people use in the HF tags, and the UHF. The UHF is also like a really fast communication. So it also provides a really fast communication, and the active tags provide the fastest communication. The reader cost for the UHF is the greatest. For the LF and the HF, readers are usually really cheap, and you can just find the modules for reading the LF and HF tags on Amazon and all those other sites that are compatible with Arduino, Raspberry Pis and all for a really cheap price. That's about, I guess, $5 or $10, 300 to 600 rupees. So you can just find these particular modules. They are dead cheap. And for the UHF, so these are really expensive, and because UHF is actually working on a really high frequency, and there is like a lot of limitations on the kind of bands that are used, and then there are like active, then there are a lot of protocols that are different for UHF, so a lot of computation is required for the UHF. And for the active tags as well, the readers are gonna cost the reader cost is like medium. It's like not that much, but yeah, it's like kind of okay. So anyways, so coming to how many tags a reader can read at the same time. So for LF, it is like really poor. It usually reads one tag at a time. HF can also read one tag at a time. But for the UHF, it can read multiple tags at a single time. So this is usually like related to the communication protocols and all that stuff that is being used. And there is like there are governing bodies for determining like what kind of communication there is just going to be between the reader and the tag. And active tags can also be read, like multiple active tags can be read. So it's also good for the active tags as well. And now here is on the right hand side of my screen, you can see an LF tag. So the LF tag usually consists of a coil of wire. You can see there's a copper coil, and then there is a chip that is attached to this particular coil. So this is usually forms an inductor, and this couples to the inductor that is present in the reader at the LF side. HF tags usually use an inlay pattern. So inlay is usually basically like you just print on a conductive material onto a polythene or something. So this usually does not contain as much turns as the LF, because HF does not require that much turns, and then it is like really thin, so it can just fit in your credit card as well. The UHF is having a different kind of antenna. This is called a dipole antenna. So this is not a coil, and the UHF, basically I just told you that this works in the EM spectrum, the electromagnetic spectrum. So this is usually using the dipole antennas. Now coming to the two important data transmission method that are being used in RFID. The first one is inductive coupling, and the second one is electromagnetic backscattering. Inductive coupling is usually like a transformer principle right here. So what happens is that a coil of wire will usually generate a magnetic field, okay, when a current is flowing through it. So that magnetic field will interact with the coil that is present on the RFID tag, and likewise the chip will actually use a MOSFET to change the inductance of the coil. So it will just short out the coil to send out pulses, and that will be registered by the reader, and then it will just transmit. That's how the data is received in this particular system. Whereas in electromagnetic backscattering, what we usually have is a dipole antenna. So this antenna will generate EIM waves, and these EIM waves are just gonna travel to the tag. The tag is just going to get charged, and it is just going to produce its own EIM waves back to the reader that the reader is just going to detect. So this is how both of these works. I'm not going to go into the detail of all this stuff, but yeah, this is the basic principle on how. So this inductive coupling is usually used with the high frequency and the low frequency tags. Electromagnetic backscattering is used with the this UHF and this ultra high frequency, the microwave tags that we talked about. So this is the basic structure of the low frequency, high frequency, and ultra high frequency tags. You can see a lot of windings are present in the low frequency tags. A fewer number of windings are present in the high frequency tag, and the ultra high frequency tags usually consist of a dipole antenna. And to be honest, this particular antenna designing and all this stuff can be done on a software. Those of you who will be interested in antenna designing, there's a software named Sonnet. So on this particular software, you can simulate each and every type of dipole antenna and just see what kind of frequency response you're getting out of that antenna. It's just like a piece of information that I'd like to give you. So those of you who are interested may download the Sonnet software as well. So going on to the applications of the low frequency RFID. So the low frequency RFID usually has application in the pet industry, where we usually inject a small chip in the pets so that we can identify them if a pet is lost. So we can just scan the RFID implant and just identify the owner of the pet. Similarly, for attendance system, we people use the low frequency RFID systems. And the third and the most important application that you all are having in your car is the engine immobilizer. So usually the key fob, even I'm not talking about the keyless entry cars that are nowadays everybody has. So I'm talking about the old fashioned cars, one in which you have to just turn a key to start the car. Those also have an RFID tag, and they use a technique called engine immobilizer. So usually within the key fob, there is an embedded, there is a really small RFID chip that is present on the reader side. So the engine immobilizer usually sends whenever you just place your key fob to, whenever you just like whenever you just like start the ignition of your car, this particular chip is being read by an RFID reader that is present within the steering column of your car, and that's how it just identifies if the right key is being placed inside the car or not. Otherwise, if the engine immobilizer detects that no RFID tag is present, usually when someone is like trying to make a key or something for a car, a counterfeit key, so the engine won't start and is just gonna cut off the fuel supply system of the engine, and the car will eventually die out. So then we just come to the application of the high frequency tags, and this particular screenshot I have just taken from a really good course on RFID that is being provided by Texas Instruments. So RFID, so high frequency RFID usually works in the range of 13.56 megahertz. So it's usually used in the medical industry. Then for the payment, I just told you, as I told you, NFCs and all. So in your credit cards, and then in the access control, so in your shopping malls and all, so these can use the high frequency, as well as the ultra high frequency is also used in the shopping malls. And then for product authentication, then public transportation, as I told you about, I just gave you the example of metro cards, and then the passport and ID. So usually your ID cards might also contain a high frequency RFID tag that will give the information to a particular reader when it is just swapped when it's just like placed in front of a suitable reader. So now coming to the UHF. So UHF is having a really wide variety of application. This is one of the widely used technologies of RFID. So right now what is being used for is in the inventory management. So I'm just going to show you a video as well, like, I mean, how effective the RFID is, like, as compared to barcodes and QR codes. Now, if you're having a warehouse and you are having multiple products in that particular warehouse, and you have to just identify and you have to just track how many products and what is the quantity of each product that you are having, you can just scan all the products at once using an RFID scanner. And then it will just give you, and it will just it will just make the entries in your database according to the tags it has scanned. So you don't need a direct line of sight for RFID. That is the biggest advantage of RFID. You don't need a direct line of sight because the radio waves are having some kind of penetration. So these can penetrate materials and all. So Then RFID is having application in race time systems to time the marathon times of the athletes and all. So we people usually supply these kind of systems where you have a battery pack integrated into a reader, and then you have the antennas. The antenna is in a form of a mat. You can see a carpet antenna. Then a bib that is being the player usually wears a bib that is containing an ultra high frequency RFID tag that will actually send out the signal to the carpet antenna, and according to that the software will actually track the lap timings and all that stuff for marathon races. Secondly, the toll roads that I talked about, so you need a lot of range for the toll roads, so therefore the ultra high frequency is used, the UHF is used. And for the automobile production, UHF is used. Automobile production, so this is actually a really good application of the ultra high frequency. What usually happens is that with automobile production, the on the chassis of the car, we usually place an RFID tag, the UHF RFID tag, that is having considerable user memory. Now, this user memory can be programmed anytime using a suitable reader that is being placed across the production line. So as soon as something is being done to a car, so the user memory is just going to be programmed for that particular tag accordingly, so that it can so that everything can be tracked, like whatever is being done with the car and all, so it can be tracked accordingly. So, for example, if the seats are being installed, the dashboard has been installed, if the spark plugs have been installed, and all that stuff. So, this is all getting tracked in real time using RFID. So this system is all automated, and no one usually goes and scan the tag. Usually, we have fixed readers that are being placed across the production line. So that is the main application of the UHF RFID. The another application that we people are supplying tags for right now is in the smart city projects. So in the smart city projects, what we usually do is we usually place UHF RFID tags at every house. So whenever the garbage collection person, so the person who is responsible for collecting the garbage and all, comes to a particular house, so he has to scan the tags for each and every house, as the tags are unique and he cannot just create fake tags for RFID and all. So it usually ensures that he collects the garbage from each and every household and he does not misses anything. Anyways, so this is we are providing about more than 100,000 to 200,000 tags to some of the state governments as well. Now coming to the UHF RFIDs. Now this is the RFID technology that I'm going to be discussing in a bit of a detail, not that much, but a bit of a detail I'm going to be discussing it in. So the UHF RFID usually works in the range of 865 megahertz to about 900 or 1 gigahertz range. So according to different countries, so different countries have different allocated frequencies for the UHF RFID. Now, the UHF RFID, for example, for North America, the allocated frequency is 902 to 928 megahertz. And the maximum power for each and every RFID system is also predefined. So we cannot exceed the power rating for, So for example, this is 0.5 to 4 watt EIRP. So that is the effective isotropic radiated power. I'm just going to talk about this concept later on. So ESIRP and the ERP, that is the effective radiated power, is measured using spectrum analyzers. So this is this one right here on the bottom left corner of my bottom right corner of my screen. You can see a Keysight spectrum analyzer. So this usually measures what kind of power we are getting out of our RFID system. So then the EIRP usually is equal to the PT, that is the output power of the transmitter, that is the reader. So the reader is just gonna output some power, minus the losses that occur in the coaxial cables plus the gain of the antenna. I'm just going to discuss about the gain of the antenna later on in this presentation. So according to the frequency band that is being allocated by each country, so they have a variety of channels that are being allocated to this UHF RFID, and the tags are usually tuned to this particular frequency range. So if you just look at the frequency response analysis for each and every tags and all, so in Sonnet software, you'll see that they will be having a peak at that particular frequency on which they are being designed to work on. So in India, usually the RFID system that we people use in India work in the range of 865 to 867 megahertz. So we people are having a 2 megahertz band, and the effective radiated power is about 4 watts isotropic power. I'm just going to talk about the isotropic power in the next slide. So Okay, anyways, now coming on to the types of UHF RFID readers. So we usually have different types of ultra high frequency readers that are being used nowadays. So we usually have, okay, someone message, wait for a second. All right. Can RFID tag be duplicated by simply using a reader to read the data off of it and create a similar tag? Yeah, that is really that is possible if your tag is not having any encryption. So usually some of the tags are gonna have encryption, and the key to the encryption is only gonna be present at the reader end. So those tags cannot be duplicated, and the data that is being received by the tag is not gonna be recognized by the reader in that particular case. But yeah, most of the tags that are being used in the warehouses can be duplicated because these are actually programmable, so you can just program the tags again and again. So the user memory can be changed, the EPC can be changed for a particular tag. So yeah, these can be duplicated. Anyways, coming to the fixed reader. So we people usually in our company, we people usually make the fixed reader that is using the Impinj R2000 chip. So there are multiple chips that are available for the readers. I'm going to talk about the chips in the later on in a later part of this presentation. So there are a few fixed readers. So this one is an 8-port reader, and this one is a 4-port reader right here. So the 8-port reader usually the 8-port reader can simultaneously take the signals from 8 antennas, and it uses multiplexing. So similarly, the 4-port reader can take the signals from 4 readers, and these kind of readers are really expensive because of the chipset that is being used. So that is the Impinj R2000. So these usually cost within a range of 100,000 to 150,000 rupees. That's about 1.5 lakh. So, and then comes the handheld readers. So the handheld readers are usually integrated devices, and these also sometimes use the Impinj R2000 or the Magic RF M100 chip. So the handheld reader usually communicate to the database via Wi-Fi or Bluetooth. And these are really convenient because you can just go around your inventory just scanning for tags, and these offer a really good range as well. The best range that we get out of is from the fixed readers because these are having a power level of up to 33 dBm. So 33 dBm, I'm just gonna explain it later on. Anyways, now coming on to some more type of UHF RFID readers that we people provide. So this one is right here on the left hand side of my screen. You can see this one is a desktop reader. Now this usually connects to your PC via a USB cable. And then there is an integrated reader. So in the integrated reader, the antenna is integrated with the reader. So this is a single unit which you have to just supply power, and you can just take the EPC and the user data out of the tag directly over the RS-232 or through the Ethernet port or through the USB port. And then there are like some of the readers are available in a very small form factor. For example, this one is a micro reader. So this can only read the RFID tags. It cannot just write the tags. All the readers that I've mentioned before that, so these all can write the tags as well, and these can read the tags and write the tags at the same time. So these are more advanced than the small form factor one, but yeah, this is actually really convenient if you want to just find out what is the EPC for a particular tag and you are just standing really close to a tag, because these do not have a really good range. Similar goes for the desktop reader. Desktop reader also does not have a really good range, and we people usually use the desktop readers to program the tags. And the integrated readers and all, so these are basically used in the toll systems. Similar goes for the Impinj, this one, the 8-port reader and the 4-port reader. These are also used in the toll system where a lot of range is required. In the warehouses, if something is like going out of a warehouse and you want to just like, and every material in the warehouse is having an RFID tag, so you can actually create a gateway system in which multiple arrays of antennas are placed that will just scan all the tags that are within a pallet. So the handheld readers also find application in toll booths as well. Sometimes the reader that is like placed above the toll road fails. So at that point of time, someone with a handheld reader just comes and scans the tag of your car. Just comment if you have faced the same issue. So I have actually faced it once. So a person with a handheld reader just came in to read the tag. Anyways, now coming to the chips for the UHF RFID. So we usually have two kinds of chips. So on the leftmost side, this is the macro shot that I have taken for a particular reader board. So this one is actually used in this one, the integrated reader. This is the M100, the Magic RF M100 chip. So this can go up to 26 dBm. So this is like a mid-level power chipset. So this usually offers a range of about 10 meter depending upon the attenuation of the antenna. And this is what the whole board looks like. So it's having a buck converter that is usually that is used for the power regulations, because it can work from a voltage range of 5 volts all the way up to 24 volts. So it has to just provide 3.3 volts constantly to the microcontrollers that are built into this. And this usually uses a 32-bit microcontroller that usually handles the communication with the Magic RF chip. So the Magic RF chip usually provides its output in the form of TTL signal, the RX and the TX. Those people who are familiar with Arduino might know what I'm talking about. So, and then it usually spits out the data in the form of RS-232, RS-485, and the Ethernet, and also through vGAN. Now, the second, and now this is actually one of the video in which I'm demonstrating how this chip works. So let's just see. This is actually a reader board, and I've just connected it to my laptop via Ethernet. So let's just see. So this is actually the antenna right here. So back here you can see this one. This is the antenna, and sorry for the crude video quality because this was not meant for the presentation, but however I decided to add it later on. And this is the PCB that is responsible for providing the power to the antenna and for receiving the signal and then transmitting to the laptop. And on the laptop you can see I've just opened up a software which is reading all the tags. So this is how this particular system works. I'm not going to go into the detail again. Now the second one is the Impinj R2000 chipset. So Impinj R2000 chipset is a really expensive chipset. So this the readers that are having this particular chipset usually cost within a range of about 70,000 to more than 100,000 rupees. So for example, this one right here, the 8-port and the 4-port reader are using the Impinj chipset. This one also uses the Impinj. So the handheld reader usually costs about 70k or about 60k. This one also costs about 100k. And the integrated user uses the Magic RF. Similar goes for the desktop reader. This also uses the Magic RF, and the micro reader also uses the Magic RF chipset, because these are actually budget-friendly kind of alternatives for the Impinj. So Magic RF is a Chinese company that is, Chinese are really good at making cheap products. So this is the Impinj, and this is actually a reader board for the 8-port reader. So the 8-port reader that I saw, so this is a Volt reader board that we usually have within the 8-port reader that you saw. So this is containing Impinj R2000, and this can go up to a maximum power level of 33 dBm. So that is a lot of power. And now the Magic RF goes up to 26 dBm. This one goes up to 33 dBm. So 33 dBm gain. So it's an increase of about 6 dBm. So right about 6 dBm or 7 dBm. So the power usually increases by a factor of 4. Let's just come to the part where we discuss about the UHF RFID antennas. So the UHF RFID antennas, they usually are specified by a number of how many dBi gain that is having. So the dBi refers to the decibel isotropic. So this is usually, so if power is being transmitted to an antenna and it is it is forming a sphere, a uniform sphere of EM waves. So the gain is considered to be at 0. So then if the antenna is directional, so most of the antennas that are there in RFID are directional. So if the antenna is directional, then the gain will increase by some amount. So this is actually calculated by this particular formula, that is dB is equals to 10 log P2 by P1. So you don't need to go into the depth of this thing, but the thing is that if the dBi is increased, then the directionality of the antenna will increase, and you won't be able to read the tags. You have to just point the reader in the direction of the tag with a greater accuracy. So that's usually the concept of the dBi. So if you are just seeing a 9 dBi antenna versus the 12 dBi antenna, the 12 dBi antenna is going to have a greater read range compared to the 9 dBi antenna. Anyways, now this is actually one of the antennas that we people manufacture in our company. So this is a 9 dBi antenna, and you can see how the plates are placed. So I'm not going to go into the antenna designing and all again. So this usually gets connected to the 8-port or the 4-port reader that I have already mentioned. And then this one is a 12 dBi antenna. Now the 12 dBi antenna we people don't usually manufacture. Similar goes for the matte antenna. So we people are the suppliers for these two antennas. So the matte antenna is usually used in the race time system to time the marathons and all that stuff. So this usually like lays flat on the floor, and it is having a gain of 6 dBi, because you actually want a wide field to just read all the tags that are passing over this particular antenna. Now coming to the antenna polarization. So there are basically two types of antenna polarization that are present in RFID. So one is the linear polarization and the second one is the circular polarization. So for the linear polarized antennas, they are actually not that common, and we usually use the circular polarized antennas, and the antennas that we usually provide from our company as well, they are all circularly polarized. So the circular polarized antennas usually offer a kind of a benefit as compared to the linear polarized antenna, in the terms of that these antennas are not directional, and these are going to read the tags even if it is like not exactly pointed at the tag. If the antenna is not exactly pointing at the tag, it will still be able to read the tag, because it's just having like the spread of the beam that is being created by these antennas is much more than the linear antennas. Linear antennas, on the other hand, have a really high read range, because it is like usually the linearly polarized antennas are directional. Not going into the details again. So, but the problem with linear antennas is that the dipole antennas of the RFID tags that we people use, so they have to be placed in accordance to the linearly polarized antenna. If it is like placed at 90 degrees, then the tag is not gonna get read. So with circularly polarized antenna, the orientation of the tag does not matter, but with linearly polarized antennas, the orientation of the tag does matter a lot. Now coming to the RFID versus barcode. Now this is actually a really interesting video clip from a YouTuber. So, and this is actually a company that manufactures RFID as well. So I'm just gonna play this clip and you'll just see how fast RFID is in comparison to barcode and the QR codes. Now going on, so this is a basic comparison table between the RFID versus the barcode. So the traditional linear barcodes usually have a data capacity of up to 24 characters. The two-dimensional barcodes is having a data capacity of 2000 characters, whereas the RFID tags is having a data capacity of several thousand characters. Now the reading requirement, you need a line of sight to read a particular tag. For a two-dimensional barcode, you also need a line of sight, but no line of sight is required for the RFID tag. The durability, the paper labels are subjected to wear and tear. Again, for two-dimensional code, the papers are subjected to wear and tear, and obviously if the printing of the paper gets affected by the ultraviolet radiation coming from the sun and all, so the barcode will become unreadable. So, but it's not the case with RFID. We usually, what we do is we just encapsulate those particular inlays within plastic housing that is like made of ABS plastic. So in order to just increase the durability, and these can just last for many years. So up to 20 years can be the life of the RFID tags. Now the efficiency is that the traditional barcode readers can only, the barcode can be, a single barcode can be read at a single time. For two-dimensional, this is even more limited, as it just takes a lot of processing power to just read a QR code. But for RFID, this usually can read multiple tags at the same time. And for read-write, so traditional barcodes are not having any read-write capabilities. For two-dimensional barcode as well, you need to print out a new two-dimensional barcode. So that is the QR code that we usually refer to as. So you do need to print out a new QR code. But for RFID, you can actually program the tag. So, but there are, however, a few limitations to the RFID. But that's the trade-off worth it, because they cost more as well in comparison to the barcode. And all the barcode is just a printout. Yeah, you're right. The RFID can cost a bit more than the barcode, but usually the cost of RFID is coming down, and compared to the advantage of RFID, for example, in the warehouse management and the time saving that it provides, it usually is a better choice to opt for the RFID. And secondly, the RFID tags can be reused. I just told you that these are reprogrammable, so these can be reused again and again. So that's a main benefit of RFID. And then the read range is also there. So it's like both of them are having their own application, but soon all the barcodes and the QR codes will be replaced by RFID. So, and the costs are also gonna get down. Like, I mean, they are just gonna come down as they just like grow in popularity. So the limitations are that the material like metals and liquid can impact the signal strength, as I told you. So if there's a metal object behind inlay or a tag, especially for the UHF, so the antenna will get detuned, and in that case the tag will not get read. Similarly for liquid, so liquid can absorb the radio frequencies, so the radio signals can get absorbed by the liquids, and this will impact the signal strength. Sometimes it is not accurate and reliable as a barcode scanner because the tag can sometimes be kept at an orientation in which it would not be readable. Secondly comes the cost of the RFID readers can be 10 times more expensive than the barcode readers. So it is usually the cost of the readers that is more in RFID as compared to barcode. So barcode readers are really dead cheap, but the thing is that the RFID readers are expensive. They are really expensive. So even the normal barcode, no, even the normal RFID reader can cost you about more than 12,000 to 25,000 rupees. So implementation can be difficult and time consuming, as you saw that we have to just place antennas in multiple places, and then you have to just connect it to the database, and then the wiring for the antenna has to be taken care of. So yeah, the implementation is kind of time consuming for RFID. Now that's the end of the webinar. So feel free to ask any questions if you have any.